Okay, so here's a problem you've probably heard before. A car travels 120 miles in 2 hours. How fast was it going? Well, back in Algebra 1, this was super simple. It had to be going at 60 miles per hour, right? Well, that answer may have gotten you an A on the test, but if you really think about it, that's not how the real world works. If you got in a car and went somewhere, you would presumably start in your neighborhood with a speed limit of around 15 miles per hour and end up on the freeway with speeds of like 65 miles per hour. And that doesn't take into account when you have to stop at a stop sign or have to slow down due to traffic. So, people came up with a better solution. What if we could measure how far our car travels over time? We can then find the rate of change of our new function and find out how fast we are going. All our problems will be solved. Wait, there's a problem. When we plot our function, our line is curved. How on earth do you find the rate of change on a curve? Well, my friends, it is time for an introduction to calculus. Now, many of you are freaking out right now and saying, calculus is super hard. But in reality, calculus isn't that complicated and has tons of real-world applications. Calculus is used every day to find out tons of numbers that are important in keeping our world running. Now, back to the problem at hand. If you want to find the rate of change on a curve, you use this thing called a derivative. There's a whole ton of math that goes in understanding what derivatives are and how they work, but simply they are functions that describe the slope and behavior of other functions. So, that probably seems really confusing, so let's make it simpler. Let's take the function y equals x squared. How on earth do you find the rate of change of something like that? Well, it is actually quite simple. For any expression in terms of x, simply go one term at a time and apply this formula. If y equals x to the n plus c, then y primed equals nx to the n minus 1. Y primed is the rate of change at any point. So y primed of y equals 3x plus 4 is 3, right? So you can take a function like y equals x squared plus 2x plus 4. Go term by term. Y becomes y primed, x squared becomes 2x, 2x just becomes 2, and the 4 disappears because it is a constant. So you get y primed equals 2x plus 2. Wait a minute, that's a function, not a slope. Well, for all curved functions, the slope depends on the x value because the slope changes. The slope starts out very small at the bottom of the curve. It gets really steep later on. So that's why we have a function to describe slope, not just a number. So, if we go back to our problem with the car, we can use our beautiful graph to figure out just how fast we are going at any particular time, not just our average speed. And that is a very simplistic introduction to the world of derivatives.